In this video, we're going to look at how we can use probability tables to solve the kinds of questions where you're looking for the intersection between two events. For those who don't know me, my name is Chris Iannazzoni. I've been tutoring for about 2 years now, and I make these videos so that VCE students can do the best they can in math methods. With that out of the way, let's get into it. The basic structure of a probability table is as follows. The top row and side column are representing the events that you're keeping track of. In that top row and column, we're also going to include the complement to those two events, which just means everything that is not that event. On the outside of the table, we have the probability that any of those events occur. And finally, on the inside of the table are all the intersections between those events. Now, the advantage of arranging things this way is that we can now use simple addition and subtraction to solve any of these intersections quite quickly. The way it works is that any vertical or horizontal addition of the cells in the middle needs to add up to give the cell on the outside, highlighted in blue. For example, the top two cells in the first column need to add up to give the probability of A. This also works for the outside column as well, where B and B prime need to add together to give 1. The reason why it equals 1 is because we're basically just saying find the probability of something occurring and then add it to the probability of everything else occurring. Whenever you do that, you've just encompassed all possible events. The table also works horizontally as well. For example, if we look at that second row, we can say that the two cells in the middle have to add up to give the probability of B prime. That's pretty much it for how they work. Let's try an example. Probability tables are best used when the information that's given to you is in the form of intersections, like this example here. Ultimately, we want to find the probability that someone does cardio but does not play sport. Mathematically, this is just an intersection between those two events. So, let's see how probability tables can help us here. I'm going to use S for sport and C for cardio. Well, we're going to start by filling out all the probabilities that we already know. In this case, we're told that 65% of people play sport. So we know that the total of the sport column needs to add up to 65%. Next, we're told that 71% of people do cardio. So the total of that row that represents cardio needs to add up to 71%. The last statistic that we have is that 53% of people play sport and do cardio. The use of the keyword "and" implies an intersection of those two events. So we're going to put that statistic in the intersection between sport and cardio. From here, we've already filled the table out with all the information provided to us. What we need to do from here is some simple additions or subtractions to get the additional pieces of information that we need to solve the question. In this case, we're looking for the intersection between cardio and not sport. If we look horizontally, we can say that 0.53 plus the intersection that we want needs to add up to give 0.71. So if we just rearrange that equation to get the intersection on its own, we're going to have our answer. Now, we have our answer, but if you want to fill out the rest of the table, then you can absolutely do so. A natural place to continue would be to look at that first column. 0.53 plus that intersection needs to add up to give 0.65. Once again, you're just going to rearrange for that intersection, and that'll give you that answer. See if you can fill out the rest yourself. Here's the completed one for reference. The good thing about probability tables is that you can self-check your answer quite easily. You have to make sure that every row and every column adds up like you expect. If you get a mismatch anywhere along the table, you know you've made a mistake somewhere. We haven't covered it in detail yet, but as you get deeper into the probability fundamentals, you're eventually going to learn about conditional probability. The problem is that these kinds of questions can look very similar to intersections, like this example here that I pulled from a past VCAR exam. At first glance, this looks like it'd be perfect for probability tables. We have two different production lines and we have faulty or not faulty. If you look at this in more detail, this specific wording actually implies a conditional probability. Let me explain. The best way that I know to figure this out is to look and see if the events in the question claim to influence each other. If we consider this VCAR example, we have evidence that the specific motor line that the motor came from will impact the failure rate of that motor. We're told that line A had a failure rate of 5% and line B had a failure rate of 8%. Being faulty is completely dependent on what production line the motor came from. Hence, this is a conditional probability, not an intersection. In contrast, if we compare to the example we did before, there is no such statistic that we can compare to. There would need to be some statement along the lines of the people who do cardio, some percent play sport. A statement like that would clearly indicate that the probability that was given is dependent on people that are already doing cardio, rather than the current wording, which just implies any random person, whether they did cardio or not. If you found this video helpful, then you should consider joining my free community. I host a Q&A call every week to personally help you through any of your specific questions, and you'll also get access to more resources like this, including written and recorded lecture content, as well as practice exams and SACs with detailed solutions. It's pretty cool. You should check it out. I'll see you there.